Hello guys, my name is Mukesh Singh and we are continuing with the domain 3, that is security engineering. In this session we are learning about PKI and cryptographic applications. So there is a asymmetric cryptography. As you remember, the last session we have learned symmetric cryptography and asymmetric cryptography. The difference between both, we are well aware, like symmetric use the same key for the sender and same for the receiver, that is symmetric cryptography. But asymmetric cryptography, the sender do have their his own personal key, public key here, and the receiver do have this own secret key here. We can check. So there are basically asymmetric cryptography as RSA, DSA, ECC, and LKML. So basically this cryptography we use in our servers or we use in our the routers. Okay, so sometime we are typing cryptography RSA, so they are based on the names, Ronald Samir Eldeman in 1088. These are the bits over there. So understand this diagram very well. Plain text, it is got encrypted. After encryption it become cipher text here. So they use some algorithm for encrypting, for example this one, okay, and then they use a key for it. So the sender do have his own key, so key do not need to be transport to the destination, not required, because he is using his own public key, whereas a receiver are using the decryption channel. He is having his own private personal key, secret key, and that key help him to decode the text messages. So one more thing with the symmetric or asymmetric cryptography, that the sender and receiver, they both should be using the same cryptography. If he is using RSA, he should be using the same RSA, like that way it works. Although when somebody using public key, so that means he is agreeing to use what the receiver supposed to use, So next is the hash function. Hash function equal to hash value is equal to checksum is equal to message digest equal to CRC, stand for cyclic redundancy check. So a hash is used to secure the integrity. As we have learned, integrity is like there is a PC1 here and sending data to PC2. So PC1 is telling I owe you $500, okay. So in middle somebody changed the message and he received like I owe you $1,500. So the integrity of message is not there. So whenever he receive a message from the PC1, he will check the hash value with the PC1. If they match, that's fine. The data is not tampered. So hash value is basically used to secure the integrity, but hash is almost irreversible, okay. So you can make it almost here irreversible. Next is input. Somebody writing a fox here, the hash function, fox will become hash sum. So here, so DFCD and something. So red fox run across the ice, so that will again become some another hash function here. The red fox walks across the ice, so hash function, and again that will be making something different. So that's a hash function. So SHA secure hash logo, actually there used to be these one SHA secure hash algorithm, sorry, not logo, secure hash algorithm, and these used to be in our old days. Here when I was learning a student, we used to use MD5, and MD5 basically message digest. So MD2, MD5 no longer used. SHA is the one we basically use for these all one. These one SHA 256 to SHA here, this one we use. We do not use 512 because it is very vulnerable to attack, okay. Here we have note MD2, MD4 is no longer accepted now. So these are not accepted. This one we don't use, the first one, because it's easy to attack. So these are the one we can use, and definitely the last one 384 and 512 is the better one to use the algorithm, okay. So where to use them? Actually, they is used when you are configuring some kind of a VPN or making a communication between computer to computer. So it can be done with sort of applications, or router to router it can be done. Okay. Next is a digital signature. Digital code generated by authenticated by public key encryption, which is attended to an electronic transmitted document to verify its content and the sender identity. So here this is a Rose Hemsworth, and there is a document. The algorithm is a document fingerprint. It is encrypted, and then it will send as a digital signature. You look, is a code actually, and when he received, here he received the document. So basically this kind of digital signatures are used in the banking system. When in a bank there are 20 employees, so the 10 employees or 3 or 4 employees, suppose in a small branch, do have access to manage the account. So with the computer password, apart from that, they do have a fingerprint password, so to make sure that they are the only one who is accessing their computer and making changes into that. So that is the one way to use for a digital signature. Plus there are multiple way to use that, but let's Hallmark, this is the one, HMAC, digital signature, but not for non-repudiations. Okay, it can be combined with any standard message digest algorithm by using shared secret key. So if a person know the key, can generate or verify digital signature. So that is the another you can look for it. Okay, next is digital certificate. This is a very common certificate we use whenever you browse a website for a banks, or today almost every website do have HTTPS. Okay, for example, so hypertext transfer protocol secure. Okay, so here if you look, this one secure. So whenever you browse a website, automatically the server generate a digital, okay, let me just explain it to you. This is a server here. Okay, and you are accessing this website over the internet, is an internet cloud. So whenever you access this website www.abc.com from here, okay, so this will create a secure digital certificate on your computer. So the communication happen from your computer to the server will be remain as a secure communication. That is the one way for the website we use this. So automatically the client will get the digital certificate for the public's website, for the banks, or for the finance one. But it can be used for another purpose, like there is a server here in a bank, and there is a website here, and there are users connected. So there are 3 user connected. I have issued digital certificate to 1 second and no certificate for the third. So these 2 can go and access the website and access their user accounts or money transaction on this one also, but the third one do not have digital certificate to go with it. So that is the another one. And there are certificate authority. There are Microsoft is the one who is having a certificate authority over there, but there are third party certificate authority. You can assign, like you can use that, or you can use that as a service. These are the one. Certificate generation and destruction we just talk about now. Prove your identity, public certificate in the last slide. So moving next to the one, applied cryptography. Email must be encrypted. First of all, whenever you make an email, aware your receiver that is an encrypted email, and he should know how to decrypt it. Okay, there is a method these days, like in a Gmail, if you send an email, the receiver receive it, but he need to add some password to access it. So here is the Outlook, Mozilla, Mac OS for email encryption. My web applications are use SSL checking. Okay, so secure server layer, this is the one. Stenography and watermarking is to be there. Okay, so next is IPsec. We will cover it in the next session. Thank you.